Okey, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. I'm Muhammad Abdul Raup bin Parsat. I'm student of Doctor of Philosophy in Electrical Engineering. This is a presentation actually for my report appropriate submission for semester October 2022 to February 2023. And my program code is EE950. And I will be supervised by my supervisor, technologist Dr. Darina Johari, and my co-supervisor, Professor Insinyur Dr. Ismail Musirin. So here's the content of my research. The first one is a thesis title. Number two is an introduction, followed by problem statement, objective, scope of study, literature review, methodology, research design, planning for next semester, and the last one is references. Okay, so my thesis title is Artificial Intelligence-Based Technique for Identification of the Transmission Line Failures and Modeling of the Tower Design in Complex Geographical Areas. Okay, this is part of my introduction of my research. So most of the line outages actually due to lightning in SSB grid has higher number of GFD. So GFD is a ground flash density. In some of the lines in SSB actually recorded has a higher number of GFD, up to 16 to 17 flashes per kilometer. So it could be direct hit or indirect hit of the transmission line tower. So usually the analysis is based on the lightning pattern shows in the DFR or disturbance fault recorder. So in SSB, when we have an event of the line tripping, so this DFR will send us the pattern of the lightning. So normally back flashover usually is related to the tower footing resistance, and shielding failure is related to the angle conductor to be protected by a wire. Okay, we go to the problem statement. So most of the transmission line outage are caused by lightning. So this is why I mentioned before, and shielding failure and backflash over two typically types of the transmission line failure. And these two types, transmission line failure, are significant and need to be identified. So this is important for improving the tower footing resistance in order to mitigate line tripping due to lightning. So one of the major issue in the transmission line in designing tower ding actually is the space constraint. Most of the tower in transmission line actually located at the top of the hill. So the space is one of the issue in designing the tower ding. Okay, so this is the objective for my research. So number one is a prediction of the backflash shower and shielding failure. Number two is the modeling of the tower ding design for complex geographical areas. And the last one is to investigate a flashover pattern in circuit for different lightning waveform. Okay, we go for the scope of study. So the scope of study for this case only in SSB grid, which will be covered from 66 kV, 132 kV, and 275 kV of transmission line. Lightning induced voltage or LIV from intra-cloud, inter-cloud are not taken into consideration. Real input data of the soil resistivity and tower footing resistance is taken for consideration. Negative, 0, and positive shielding angle of tower are taken consideration only for the conductor above the ground, and real time sensor of lightning in substate is to be used in this study or throughout this research. Okay, so this is the literature review. So these are 5 parameters actually is a utility engineer's concern. So number one is the crest current for the first and the subsequent stroke. And number two is current wave shape. And number 3 is the correlation between the parameters. Number 4 is the number of the stroke per flash. And the last one is very important parameters is the ground flash density or GFD. Okay, so 2 different cases of the transient overvoltage in transmission line. So number 1 is the shielding failure. So what is what is shielding failure? So direct strike to the path conductor result in the associated current splitting into two halves, which travel back and forth to the struck conductor. So the traveling wave generated is given by V in terms of T is 0.5 multiplied by I in terms of T ZP, where the ZP is the surge impedance of the path conductor is given by ZP is equal to square root L over C. L and C are the series inductance and capacitance to ground per meters of the path conductor respectively. Okay, so number 2 is the back flashover. What is the back flashover? When the lightning strikes to the shield wire, the current will propagate in both directions along the shield wire and down to any tower in propagation path. When the current reaches a certain level, the striking tower's voltage will increase enough to cause back flashover by flashing through the insulation of the line. The three important voltage equations are the crest voltage, VTT, the voltage at the top of the tower, BT, prior to reflection from the footing resistor, and the last one is the final voltage, VF. The equation for VT is given by VT equal to T multiplied by E over TF equal to ZT multiplied by T multiplied by I over TF equal to LT multiplied by I over TF. And VTT is in bracket RE plus alpha TZT TF over the TT over TF, multiplied by I, and VF in bracket 1 minus alpha T multiplied by E equal to REI. So the current IR and the voltage VR, the footing resistance, is equal VR RI multiplied by ZT equal over ZT plus RI, and IR equal to ZT over ZT plus RI multiplied by I equal to Ri multiplied by I over Ri. So this is the continuous of the literature review. So the lightning which strike to the ground, wire of the lightning can create different pattern of flashover on the path conductor. So the pattern are depending on many factors such as lightning current magnitude, front and tail time, characteristic of transmission line tower, position of the path conductor, tower grounding, and striking distance. And this is a lightning current model mathematical framework. So in this study or throughout the research, so this current model will be used. So this current actually is recommended by IEC 62305-1 edition 2 and will be selected in this study. And this current model is called a Heidler function. Okay, so this is a methodology. Okay, number 1 is modeling of a DING tower by using the computer software. And number 2 is a developing of ANN for predicting of the back flashover and shielding failure. And the third one is a simulation through the computer software. Number 4 is comparing the result of the simulation with the other published paper. The fifth is the installation of a DING tower at site. And the last one is a measuring of line performance for new design of the tower DING. Okay, we go to Gantt chart. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of the activities. And for the semester 1 in October, actually is for the registration, and November is the nominating of the supervisor. And literature review, it takes 3 months from December 2022 to February 23. And also at the same time, we try to get approval of the collaboration or the approval of the data sharing and working tools to be used throughout the research. And this approval is takes from the January to March 2023, and data collection also takes 3 months from the March 23 to May 23. And the research design started from April 23 to May 23, and modeling of the tower being developed at ANN and simulation with software is start from May. to July 2023. And for semester 3 and 4, for installation of the tower ding at site and align performance measures. Okay, so we go for the research design specification. So the research approach is a quantitative. Research type is applied. Data type is secondary. Data collection method is mathematical analysis, simulation, and experimental verification. And this is a planning for next semester. So number one is finalizing the research design, if required, and a modeling of the tower ding and simulation via computer software, and develop an and fault analysis in a power system. So this fault analysis, we go into depth to analyze the fault analysis due to, or especially in the lightning. Okay, this list for the references, and this is appendix 1. So this is a letter of the application for getting approval to data sharing or usage of the working tools in SCSB. So as a comment from the general manager of the transmission, so this application will be presented into 3 levels of the platform. So number 1 is a TTC, a transmission technical committee. This will be chaired by the general manager. And second level is AMAR, Asset Management and Review Transmission, and will be chaired by a senior general manager. And the last one is MCM, Management Committee Meeting, and will be chaired by the CEO. So hopefully we can get the approval to proceed or throughout this research. And that's all from me. Thank you very much.